In this clip, I'm going to use two examples from Maths Quest 11 to show you the method of elimination. In this particular method, we solve the equations by eliminating one of the variables. In this case, we're going to eliminate the y variable from these equations. We're going to do it by changing this equation here so that it says negative 10y here, and then we're going to add the equations to eliminate the y. To do that, we follow this method. Label our equations 1 and 2, and we're going to multiply equation 2 through by 10. So all of this is going to be multiplied by 10. So it's like having 10 lots of equation 2. 10 lots of 3x will be 30x, 10 lots of negative y will be negative 10y, and 10 lots of 12 will be 120. I'm going to call that equation 3, and just for neatness and because it's going to keep it in our view, I'm going to rewrite equation 1 here. 9x plus 10y equals 153. That's equation 1. We're going to concentrate on these two equations. What we notice is that if we combine these two equations, y will be eliminated because negative 10y and positive 10y will combine to give nothing. If that had been a positive 10y and that had been a positive 10y, we'd have to take one of these equations rather than add them. So we're going to add, because we know it's going to eliminate the y. So we're going to add equation 1 and equation 3. That and that gives you 39x, that and that gives you nothing, and that will give you 273. Now we've got one equation in one unknown, so we can solve that. In this case, we're going to divide both sides of the equation by 39. And 39x divided by 39 is x, that's why we did it. And 273 divided by 39 comes out to be quite nicely as 7. So x is 7. Now what we're going to do is we're going to substitute x equal to 7 into one of the equations, and I'm going to substitute into this equation 2 because it's a simpler one. Writing down equation 2 here so we can see what it is. Substitute x equal to 7 into it. 3 times 7, take y, equals 12. 21 minus y equals 12. Take 21 from both sides to solve that equation. That'll cancel with that. So we have negative y is equal to negative 9. And if negative 9, y is equal to negative 9, then y must be equal to 9. So the solution set to this equation is x equals 7, y equals 9. You could write it like that, or you could write as solution is x equals 7, y equals 9. In example 2, I think we're going to get some rather more difficult numbers to work with, but let's have a go with this one. Label equations 1 and 2 and have a think about how you're going to eliminate one of the variables. We could do it by multiplying this equation through by 4 and getting negative 12x, and then multiply this equation through by 3 and getting negative 12x and eliminate the x. But I think it might be simpler to multiply equation 1 by 2 to get 2y and then take the other 2y equation, the equation with 2y in it, away from it. Let's do that. So equation 1 by 2. Negative 6x plus 2y equals 16. Call that equation 3. And that's been generated out of equation 1 by multiplying everything in equation 1 by 2. Now we're going to write, no, we won't write that. We'll have a look at these two equations. We're going to look at these equations here and see how we can eliminate y. And we can eliminate y by taking this equation, equation 3, away from equation 2. So we'll do that. So it'll be equation 2 take equation 3. So it's 4x take 6x, so it's 4x take negative 6x actually, plus 2y there, take positive 2y, equals 21 take 16. 4x take negative 6x will give us 10x. 2y take positive 2y will give you nothing. And 21 minus 16 will give us 5. Now we divide both sides of that equation 10 to get what x is. And so we have x equals 5 over 10, which is a half. So We've now eliminated y, and we've found that x is a half. Now we have to substitute this back into one of the equations to find out what y is. We'll substitute it back into the simplest equation, which is equation 1, I think. Might be nicer. Although, no, I'll substitute it back into equation 2. The reason I'm going to do that is because I've noticed that x, if we put x equal to half, we'll have a 4 times a half will be 2, and we'll have a nicer equation to work with. So I'll substitute it into 2. So we have 4 times x plus 2y equals 21. That's our equation 2. Substituting that in, 4 times a half plus 2y equals 21. So 2 plus 2y equals 21. Take 2 from both sides to get rid of that 2. So we have that cancelling from there and there. We'll have 2y equals 19. Divide both sides of that by 2, and you'll have y equals 19 over 2. So there's our solution for y. So our solution set is x is half. Y is 19 halves. And just to finish off again, just remember that we have 2 simultaneous equations. They can be represented by lines on a graph grid, and if we drew those 2 lines, they would intersect at the point which has the coordinates a half, 19 halves, or a half, 1 over 2, 19 over 2.